This is your all things graph. I'll do only problem number 1, and I will let you handle the rest as a worksheet in class. Let's complete the square on the first one. I'll factor the negatives, having negative x squared plus 2x minus 3. And from here, I will use my half box square. Keeping the negative in front, half of 2 will give me x plus 1 squared. If I square the 1, I'm supposed to subtract 1, but with this negative, I will add the 1. Adding the 1 uh, to the 3 will give me a total of 4, giving me plus 4. Again, I'm distributing this negative back on this one as well, because I could factor just this portion, leaving it as plus 4 on the outside. It's up to you how you want to complete the square. But this is the final product. From here, what I would do is, I know that my vertex is at the point negative 1, 4. So at negative 1, 4, I have a vertex. I'll put a point there. I will plug in 2 here to know where is my change, where I have a solid point in a hole. Remember, less or equal will be a solid. This one will be an open circle. By plugging 2 into the equation, you will end up with negative 5. If I plug in 2, I will have 2 plus 1, which is 3. 3 squared is 9. With a negative, that's negative 9 plus 4 is a negative 5. So at 2, I have negative 5. I'll put an open circle at 2, negative 5, meaning here. Well, it's actually a closed circle because I have all equal. Now I will go ahead and find my intercept. If I plug in 0 for x, I will end up at negative 1 plus 4, meaning 3, which is here. If you set this equal to 0, you will end up somewhere here. And you will now graph your parabola, knowing that it stops here, but it will keep going at this level. Now I will do the same thing for the absolute value function. For the absolute value function, I will start by plugging 2 in here. If I plug in 2, I get 2 minus 4, all inside the absolute value minus 3, which is equal to 2 minus 4 is negative 2. Absolute value of negative 2 is 2. Minus 3 would be negative 1. So at 2, I'm at negative 1. Instead of a solid point, this time I have an open circle. The vertex here is at 4, negative 3, meaning somewhere here. All I need is another point because I know the behavior of the absolute value. So I'll plug in 5. Why not? 5 minus 4 is 1. 1 minus 3 is negative 2. So at 5, I'm at negative 2. From here, I can actually graph my absolute value function. All right, the first transformation says graph absolute value of f of x. To graph the absolute value of f of x, you need to first notice that I'm assuming that it goes through this point here. That point will not move. The point here, which is my other x-intercept, this yellow point, will not move either. So I'll put a point there. I'm just selecting all the points that will not move after the reflection. Anything that was located above will remain above, meaning this point was there. This portion of the parabola will remain the same. And this portion of the graph will remain the same. The place that will change is whatever was on the bottom. So the first thing that was on the bottom was this point. I will transform this point, and that point was at negative, it was actually at 2, negative 5. So instead of 2, negative 5, it's now going to be 2, positive 5, and I have a solid point. And this is the end of my quadratic. This portion will just be up here. Now, the open circle was originally, at 2, negative 1. Instead of 2, negative 1, it's going to be at 2, 1. Now, my vertex was at 4, negative 3. Now, it's going to be at 4, positive 3. And I believe that's enough for me to make my absolute value function. All right, let's do the same thing for the last one. This time, by the way, this is just absolute value of y. This, on the other hand, will be left 3, then up 2. I will go ahead and transform this graph. Again, I'm going to transform important points. Which one are my important point? This is an important point. These two are important points. Of course, the vertex is important, and this vertex as well is important. Let's go step by step. I will start with my solid point. For my solid point, I will go ahead and shift it. Starting normally at 2, -5. I will shift that solid point. Again, I'm starting here. I'm shifting that solid point left 3 and 2 up. After doing left 3 and 2 up, the solid point turns out to be here. I will do the same thing for this intersection. This intersection here, I will do, starting at this point, I'll do left 3 and 2 up. It will now be here. Now I'm picking the vertex. Once again, I'm using this point, I'll use the vertex, and I'm probably going to transform this. I'm trying to do all these 4 x's. So far I got 2, meaning I have this and this. All right, I will take now the vertex, which is normally at -1, 4. -1, 4. 3 units to the right, 2 units up. And I will end up here. And I will take this last point, which is at 0, -3. And it will shift 3 units to the left, 2 units up. And it will give me this. From here, I can actually graph my quadratic. Alright, the quadratic will therefore look like this. Note that this point is solid, but this one, it will continue. Now I'll go ahead and transform also my absolute value. But for my absolute value, I have 1, 2, and 3 points important. Let's start with the open circle. For the open circle, it's normally at 2, -1. So instead of 2, -1, I will shift it 3 units to the right and 2 units up. My open circle will now be here. The little X mark that I have as a vertex here is normally at 4, -3. So this is the original position. After shifting 3 units and 2 to the right, I will end up here. And the last one is apparently at 7. So from here, I will shift it 3 units to the right and 2 up. And I can now graph my final quadratic or my final absolute value function as follows. You will complete the rest in class.